Hi there, this is Mike and Shawn again. Before we start today's demonstration, I'd like to give you a quick review about what we did last time. Basically, last time we used the virtual testing system to perform the profile self-optimization, or PSO. And the goal of that is to obtain the optimized profile transition time and to achieve the accelerated fatigue testing. So in the virtual testing, we have some models running that include the servo valve, the actuator, the hydraulics, and the test article. They are all running on real-time target PC. But we did use the real flex test controller hardware to drive that virtual plant. So the advantage of that is then we can use the powerful AeroPro feature. So therefore, we are really running a hardware in-the-loop simulation. We started with a profile that has 120 seconds long. Then we did the PSO. We can reduce that test duration to about 60 seconds. The next step, we tried the CCC and further reduce the test duration to about 28 seconds. And finally, we run MAC, and then the duration becomes 24 seconds. So the question now is, we spent several days running PSOs on those virtual systems. Are those profiles even realistic on the real hardware? So that's what we are going to find out today.
As Shawn mentioned, previously we ended up with a number of profiles that we had optimized using various parameters such as CCC or MAC or just using a slew rate. And we ended up with multiple different types of transition times. We also had a number of different tuning parameters for each of those profiles. Today we're going to run each of those profiles on our real hardware with the same parameters that we had in the virtual system, see how well they run, and see if we can successfully run without triggering null pacing timeouts, interlocks, or going unstable at all. So that's going to be the goal for today. Lastly, after we run that last profile that we created when we did a PSO optimization with MAC on, we're going to take that profile, run it, and run one more PSO on the real hardware and see what type of transition times we get from that. So we've got our first profile here running actually. This was the profile that we created on the virtual system where all we used was a slew rate to define the transition times. So the transition times between the end levels are all going to be just based on a slew rate. We haven't done a PSO on this one at all. And as you can see, it's running pretty well. The overall profile transition time of this one is about 120 seconds. And what do you think, Shawn?
Yeah, I think it's actually really good. You can see that for all the four-actuators, the command and feedback are following each other very well.
Yeah.
I'm happy about it.
And all we did was just pull all the parameters that we got over on the virtual system directly over to the real system. We're able to successfully run this without triggering null pacing timeout or any limit checks. We're not interlocking at all, so it looks pretty good. Alright, so we've got our second profile running here. This was the profile that we did just an initial PSO optimization on to get better transition times. We dropped it from about 120 seconds for the total profile transition time to about 62 seconds on this one. And as you can see, the transition times are no longer just based on slew rate. This is kind of determined based on the different stiffness modes that we're loading on the system. And that's the nice thing about PSO. Nice thing here is that we're able to take everything that we did in the virtual system, all that optimization, all those parameters, and pull it right over and still successfully run on the real system.
Yeah, seems like we didn't waste the entire one day to optimize on the virtual system. So that's the purpose of virtual testing. Then before you have the real system, you can come up with a pretty decent profile to run.
And just run right away, absolutely. Alright, we've got our next profile running here. This is the one that we turned CCC on for and ran a PSO on. That one brought us down to, what was the transition time on this one?
I think it was about 28 seconds.
28 seconds. So much faster than what we were running previously. We have all the parameters that we did on the virtual system brought over. Clearly there are some things that we don't necessarily model in the virtual system, such as pin slot, that we can see in our graph here. That is something that we need to address on our physical system. But we're able to successfully run without triggering null pacing timeout or any interlocks happening, and we're able to still keep up with this.
Yeah, the important thing here is that then you can use the virtual system to tune your CCC parameters.
Yeah, absolutely. You can do CCC and Mac all on the virtual system before bringing it over to real hardware. All right, we're running our last profile here. This is the profile that we got from the virtual system by running the model assisted compensator over there and running PSO. When we got the profile transition time was about 24.3 seconds. We did one more step over on the real hardware. We ran PSO one more time on the real hardware and ended up with a transition time of 25.7 seconds. So a little bit slower, but very close, and we're able to bring all the parameters over and successfully run without tripping interlocks, without going unstable or any of that. And that tells us that our virtual system is a very good prediction of our performance of our test rig. So we're able to do all of this on the virtual system without even looking at physical hardware, meaning that you can do all of this before your test rig is built and then feel comfortable putting it on your test rig and hitting the ground running.
Through this video series, we hope that you can realize the important value that virtual testing can bring to your lab. First of all, it can help you to improve your test design, meaning you can properly sizing your test hardware. And the second, you can optimize your test profile, tuning all the test control parameters before you even have a test rig. Thirdly, virtual testing bed will be a perfect tool for you to train your test operator, because everything happens in the virtual world. You will not destroy any hardware, but still you can take advantage of all the features in AeroPro. That is as if you are operating a real test.
Yeah, and make sure to check out the other videos that we have here on our site, and stay tuned for more videos to come from our Aero Checkout Lab here at MTS.